It's crazy to think, but, there are AI systems now that can basically be thrown into a brand new video game.
Oh, wow.
One they've never even seen before.
Yeah.
And they can not only figure out how to play it, but they get so good at it
Right.
that they can actually beat really experienced human players.
It's wild.
It's pretty wild, right?
Yeah.
And if you find that as fascinating as we do, and you want to hear more of these deep dives into the world of technology,
Definitely.
be sure to subscribe to the channel.
Absolutely.
But for today, that's exactly what we're going to unpack.
Like,
how does AI actually learn?
right.
We're going to try and break it down, give you a clear understanding of the principles without getting bogged down in the jargon.
The core ideas.
The core ideas.
Yeah.
Man.
It's a really intriguing question when you think about it.
It is.
It's like, how do these machines gain expertise?
Right.
Without us having to, program every single step. Makes you wonder, what are the actual fundamental mechanisms that are going on there?
Yeah.
So our goal today is to kind of give you a framework for understanding
I like it.
the ways that AI develops these abilities.
Perfect.
Yeah.
So to start off, maybe we can think about just how we as humans learn.
Okay.
So imagine learning to ride a bike.
Yeah.
You don't just hop on and know how to do it.
You're wobbling all over the place.
Yeah, you wobble a little bit. You might fall off a couple times.
A couple scrapes and bruises.
Exactly. And each time you fall off or you lose your balance,
Yeah.
that's information for you.
Feedback.
That's feedback, right?
Yeah.
Like your brain's registering what went wrong.
Exactly.
And then you make adjustments and you try again. And eventually you figure it out. Stay upright.
Until you do it.
Yeah.
Yeah.
And that whole process of getting feedback and kind of tweaking your approach.
Trial and error.
Yeah, trial and error.
Yeah.
It's similar to how AI learns.
It's that core idea of learning from experience.
Right.
And refining your behavior based on the outcomes.
Yeah.
That's really at the heart of it.
And so if we connect that back to the big picture,
Yeah.
I think that bicycle example really touches on the core of what machine learning is all about.
It does.
Right.
Yeah.
So essentially, machine learning is this field within AI that gives computers the ability to learn from data without us explicitly programming every single step that they need to take.
Yeah, it's this idea of moving away from rule-based programming.
Oh, okay.
Where you have to define everything very precisely to more of a data-driven approach.
Got it.
Where the system can kind of discover patterns and make decisions based on what it's observed in the data.
So instead of saying, a cat has pointy ears and whiskers, we just show it thousands of pictures of cats and say, these are cats.
Exactly. And the AI figures out.
And it figures it out.
What are those key features that define a cat?
Cool.
Yeah.
So within machine learning, this learning happens in a couple of different ways.
Yeah. Several key approaches.
Yeah.
One of the fundamental ones is supervised learning.
Okay.
And you can think about this back when you were in school, learning a new subject. You probably had a teacher who gave you examples.
Right.
And then the answer's right.
Yeah.
So this is kind of the same idea.
Okay.
We give the AI labeled data.
Okay.
So these are examples where we already know the outcome that we want.
So it's like the cat pictures are labeled cat.
Exactly.
Or an email is labeled spam or not spam.
Right. So in image classification, you're basically showing the AI a bunch of pictures.
Yeah.
And for each picture, you tell it what it is.
Right.
This is the cat, this is the dog, this is a bird.
Okay.
And the AI learns to associate those visual features with the label.
Got it.
So then you can show it a brand new image, and it can say, okay, based on what I've learned, this looks like a cat.
Right.
Or this looks like a bird.
Makes sense.
And similarly with spam detection, you're giving it a bunch of emails that have already been classified.
Okay.
And it learns to recognize, okay, what are the patterns in the language?
Yeah.
What are the things about the sender that might indicate that this is spam or not?
Got it.
So the key here is it's learning from examples where it knows the answer.
It knows the right answer, but what happens when you don't have those labels?
Yeah, that's a great question.
What if you just have a bunch of data and it's not neatly categorized?
Right.
So what happens then?
So that's where unsupervised learning comes in.
Okay.
And in this approach, we're giving the AI data, but it's unlabeled.
Okay.
And its job is to kind of discover hidden patterns, structures, or groupings in that data all on its own.
So like a detective.
Yeah, like a detective looking at clues.
Yeah.
Without knowing in advance what they're looking for.
Right.
Just trying to piece things together.
Cool.
Yeah. So nobody is telling the AI these data points belong to group A. these belong to group B.
Right.
It has to figure that out on its own.
And so a classic example of this is something called clustering.
Yeah.
So imagine you have a ton of data from customer transactions.
Right.
The AI can actually identify different segments of customers based on their buying behavior.
Yeah.
So maybe one group always buys the expensive stuff.
The high-end items.
Right. And another group is all about the discounts.
Yeah, bargain hunters.
Yeah, bargain hunters. And then you have another group that kind of buys everything.
A little bit of everything.
They're all over the place.
Yeah, the variety seekers.
Yeah, the variety seekers.
Yeah, and the AI can find these different groups without being told that those groups even exist.
That's amazing.
Yeah, it's pretty cool.
So it's finding its own organization in the data.
Exactly.
That's really cool.
Yeah, and another really important application of unsupervised learning is anomaly detection.
Okay.
So this is where the AI is looking for data points that are unusual, that don't fit the normal patterns.
Got it.
And this is really useful for things like fraud detection.
Right.
You know, if you're a bank and you see a transaction that just looks really weird, the AI can flag that and say, hey, this might be fraudulent.
That's super helpful.
Yeah, it's really powerful.
So we've got learning from labeled examples with supervised learning.
Right.
We've got learning from unlabeled data.
Finding the hidden structures.
Right.
With unsupervised learning.
And then what about when we hear about AI learning to play like complex games?
Right.
That doesn't always seem like it neatly fits into, these categories.
Yeah, you're right, because sometimes there aren't those clear labels.
Right.
And it's not just about finding patterns in existing data. It's about learning how to interact with an environment.
Okay.
And make decisions.
So this is where reinforcement learning comes in.
Exactly. So remember our bike analogy.
Yeah.
Imagine now you have a coach who's giving you encouragement when you're doing well.
Yeah.
Maybe a little bit of advice when you start to wobble.
Okay.
So reinforcement learning is kind of like that.
Okay.
You have the AI, which we often call an agent, interacting with an environment. And it can take actions.
Right.
And for each action, it gets feedback
in
the form of rewards or penalties.
So in a video game, that would be like getting points for doing something good.
Yeah, exactly.
And then losing points.
Or losing a life.
Yeah, for messing up.
Right.
Okay.
And the goal of the agent is to learn a strategy that will maximize its rewards over time.
So it wants the most points.
Exactly. It wants to win the game.
Got it.
And it does that through this process of trial and error. Exploring different actions, seeing what happens.
Yeah.
And figuring out, what leads to the best outcomes.
And that's how it gets so good.
Yeah, that's the basic idea behind how AI can learn to play these incredibly complex games.
So that's like chess.
Chess, Go, all those Atari games we talked about.
Yeah.
Where they can actually outperform humans.
Yeah, it's amazing.
It's pretty wild.
So we've got these different ways of learning.
Yeah.
Learning from labeled examples.
The supervised, learning from unlabeled data.
Unsupervised, finding the hidden structures.
Right.
And then learning through rewards and penalties in an environment.
Reinforcement learning.
Reinforcement learning.
Yeah.
But it seems like all of these, they really rely on having something substantial to learn from.
Absolutely.
So is data the key here?
Data is absolutely crucial.
Okay.
It's the fuel for the AI learning process.
Okay.
These models, especially machine learning, they're trained on huge amounts of data. Wow. And the more data you give them, and the better the quality of that data, the better the AI is going to be at recognizing patterns.
Okay.
Making predictions.
Yeah.
And adapting to new situations.
Got it.
So, for example, if you trained an AI to recognize different types of birds, but you only showed it pictures of birds from, like, North America,
right,
it might have trouble identifying birds from like Australia or South America.
Right, it wouldn't have seen those before.
Exactly.
That makes sense.
So the richness and the diversity of the data is really important.
It's like saying if you only study one chapter of a textbook,
right,
you're not going to do well on the whole exam.
Exactly. You need that broad exposure to different types of information.
Makes sense.
Yeah.
So data is like the fuel. And then we briefly touched on algorithms. Yeah. Can you explain what those are in the context of AI learning?
So you can think of algorithms as the sets of instructions or like the recipes that guide the AI in this learning process.
Right.
So these are the mathematical models that the AI uses to analyze the data, find those patterns, and ultimately make predictions or decisions.
So different types of machine learning use different algorithms?
Exactly.
Okay.
So in supervised learning, you might have things like decision trees.
Okay.
support vector machines.
Yeah.
Or different types of neural networks.
Okay.
And then in supervised learning, you might have clustering algorithms like k-means.
Okay.
Or dimensionality reduction techniques.
Got it.
And then in reinforcement learning, you have algorithms like Q-learning that help the agent figure out what actions to take to get those rewards.
That makes sense.
So you don't need to understand all the math.
Right.
But it's helpful to know that there are these kind of structured processes, these formulas that the AI is following to learn from the data.
Got it.
Yeah.
So we've talked about how it works in theory. Where do we actually see this happening in the real world?
Right.
Like, where are these different types of machine learning actually being used?
Yeah. Well, it feels like AI is everywhere these days.
It does.
And machine learning is a big part of that.
Yeah.
So one example is recommendation systems.
Okay.
So when you're on Netflix or Amazon and it suggests movies or products you might like, that's machine learning.
Magic.
Right. It's analyzing your past behavior and the behavior of millions of other users to predict what you might enjoy.
Yeah, and it's scary accurate sometimes.
It can be.
Yeah.
It's pretty amazing.
It is.
Another really important area is medical diagnosis.
Okay.
So machine learning algorithms are being trained on huge data sets of medical images.
Wow.
And patient records to help doctors detect diseases like cancer earlier.
That's huge.
Yeah, it's really powerful.
And what about self-driving cars?
Yeah, so self-driving cars rely heavily on reinforcement learning because the AI has to make so many real-time decisions in this complex and constantly changing environment.
Yeah, it's out there on the roads.
Exactly. And it has to learn from its mistakes to navigate safely.
So every time a self-driving car makes a decision.
Yeah, like a split-second judgment call.
Yeah.
That could be reinforcement learning.
Wow. That's amazing.
Yeah. And we also see machine learning in things like personalized advertising.
Okay.
Where the ads you see online are tailored to your interests.
Yeah.
Based on your browsing history and fraud detection systems.
Okay.
So when you use your credit card
and
the bank flags a suspicious transaction, that could be machine learning.
That's super useful.
It is.
So we've got supervised learning, unsupervised learning, reinforcement learning.
Yeah, the three main paradigms.
All driven by data.
Exactly.
And guided by these algorithms.
Right.
It's incredible how much machine learning is already shaping the technology that we use every day.
It really is. It's transforming so many aspects of our lives.
Yeah, and it's only going to continue.
Absolutely. This is just the beginning.
So given all these different ways that AI can learn, what do you think is like the next big hurdle?
That's a great question.
In creating truly intelligent machines?
Yeah.
Like systems that can really learn and adapt the way that humans do.
Right. Like reaching that human level of flexibility and understanding.
Yeah.
It's a big challenge.
It is.
But one area that I think holds a lot of potential is this idea of integrating different learning paradigms.
Okay.
So imagine an AI that can seamlessly use both labeled and unlabeled data. Or an AI that can take what it's learned in one context and apply it to something completely new.
Right, like we do.
Exactly like humans do.
Interesting.
So this ability to learn more flexibly and generalize knowledge more broadly.
Yeah.
I think that's going to be key.
Okay.
Yeah.
That's something to think about.
It is.
Well, this has been a really fascinating deep dive.
It has.
Into how artificial intelligence learns.
Yeah.
If you enjoyed this exploration and you want to see more in-depth analysis
or deep dive
of the cutting edge of technology, please subscribe to the channel.
Absolutely.
We have so much more planned, exploring the world of AI and beyond.
We're just getting started.
So thanks for joining us.
Thanks, everyone.